sometimes we have this one. Sometimes we have this one. But then please, our main focus are on this one. So the reason why I'm starting with arrows is basically for you to understand that this arrow it means what and the other one it means what. Net. So we have this arrow that we see whenever you have our two substrate or rectangles coming together, then where they're going to form a product. Now, majority of us we see this arrow, sometimes we see this one, but then we don't understand what does this arrows mean. So this arrow means that the reaction it can move from what the reactants to product and also from product to reactants, meaning that the reaction is reversible. Right? The reaction is reversible. Then this one, or actually this one its own, if it's just an arrow pointing on the product, it means that only the forward direction when we are forming a product is favored. The reaction is what? Irreversible. Does it make sense? Then this one it means that it talks about whether the equilibrium is being reached or not. But at only a level we are not focusing on that. The main goal for this is for you to be able to understand that what is the concept or the whole idea of this reaction, right? But the majority of time we just using this one if you have been asked to draw a certain reaction, or this one. Now let's focus on those two because these are the ones that we have a lot to deal with. So we have what we call a half-hooked arrow and a full-hooked arrow. Hook, I'm talking about this thing. This one is half, this one is full, right? So first thing that you need to know that this one, it means that if you see a reaction having a curved arrow that is half-hooked, it means that one electron is being pushed or is being transferred. And this one means two electrons are being transferred. So half-hooked curved arrow, it means that one electron is being transferred, we have full one. Actually, by just looking at this, you can tell you that whenever you see if one is half, it means that one electron, one, two, is two electrons. That's how you can be able to claim. Because if we require to show if whether we have, we're going to look for another one. So, half-hooked arrow and full-hooked arrow. Now, we have what we call bond making and bond breaking. So, in a chemical reaction, if we have water reacting with carbon dioxide or bicarbonate reacting with sulfuric acid, they're going to give us a what? A certain product, right? So when we talk about bond making, bond breaking, we basically try to find out that if that bicarbonate were to react with sulfuric acid, then what's happening in terms of electrons? But then for the concept of electrons, we need to understand that what is a bond? What is bond idea? Because we see that when things react, we have a bond. Within a water molecule, we have what we call a polar covalent bond. What is a bond? If you were to be asked that, you need to explain that, what are you going to say? So, we have what we call electrons. Right? So, electrons are the main idea behind the concept of forming a bond. So, if I have carbon or oxygen bonding with two hydrogen, I have water molecule like this, right? we said that these things they form a bond. But the question is, what is this bond? What does it hold here? So, from inorganic chemistry, from your basic understanding, you are asked to know, or you know that hydrogen, it has how many electrons on the shell? Anyone to guess or to give me an answer? One, right? Oxygen, how many orbitals? And how many electrons in the valence shell? Like oxygen. On the outermost shell, how many electrons? Anyone? On the outermost shell, how many electrons does oxygen have? 6. So, if oxygen has 2 valence electrons, then how many electrons does it need so that it can be stable? How many? Wait. Anyone? How many electrons does oxygen need so that it can be stable? It needs 2, right? Now, why 2? Remember, we have the first rule that explains the first shell and the second shell. The first shell, it must have how many electrons? 2, not more than that, right? This one is the octet rule, it must have 80. So, it means that oxygen has how many on the outermost? 6. Now, according to the rule, it must have 8, right? It needs how many electrons so that it can be stable? 2. Then, for you to be able to determine that how many an element or an atom is going to bond, it is determined by the number of electrons that it needs so that it can be stable. Do that make sense? Is there anyone does not understand? If you don't understand, raise your hand before I move forward. Does it make sense? I'm saying that for you to be able to tell that an atom, it has to bond how many times, you can be able to check that by looking at the outermost electron to see how many electrons that it does it do so that it can be stable. So that that particular cycle or that particular orbital, it can be full. But then it is not always the case if we have things like lithium. Lithium, it has how many orbitals? 2, right? How many electrons in the outermost shell? 1, right? Now the question is, how many electrons does lithium need so that it can be stable? Okay, let's go back a little bit. We're saying that oxygen, it needs 2 electrons so that it can be stable, because in its outermost shell, it has got 6 electrons, whereby the rule said I must have 8 electrons. Now, we can be able to tell that oxygen is going to bond 2 times. But it is not always the case, because we've got some other elements that needs more electrons so that they can be stable. For example, lithium, it is like this. It needs 7. The question is,